Thank you. I didn't have a very inspirational story. I never wanted to be a marine scientist, but then wanted to be an astronomer or a medical scientist, but then I moved from the Bavarian mountains to tropical Australia, and now I'm still researching coral reefs as a postdoc, so it's probably a bit too late to do 180 and go back to other things, and might as well continue to contribute my time towards resolving some of the critical information gaps that have accumulated in this space. You've probably read it already now. I'm talking about a project that's also funded by the CCIP, which investigates predation rates on adult Crown-of-Thorns Starfish relative to fisheries management zones on the GBR. Some of the current collaborators for this project include Scott Ling at UTAS, as well as Sterling Tebbett and Andy Hoey at JCU. We all know that reef health and resilience are inherently contingent on moderating some of the major disturbances, such as the ones shown here in these photos. While slightly overshadowed by 5 major mass bleaching events in the past 8 years, it's important not to forget about these other ones, like tropical cyclones and Crown-of-Thorns Starfish, which are the other 2 major contributors to reef degradation, both in the GBR Marine Park as well as the broader Indo-Pacific region. The problem is 2 of these 3 major disturbances or contributors to reef degradation, bleaching and cyclones, are disturbance events that we cannot really resolve or even effectively moderate at the scales most of us here operate, which leaves us with only one of these major contributors that is at least somewhat amenable to localized management efforts. Because Crown-of-Thorns Starfish continue to devastate reefs and entire regions throughout the Indo-Pacific range, it appears critical to capitalize on the opportunity to build reef resilience by understanding their population eruptions and outbreaks and contribute to the ecological underpinning of COTS management. On the GBR, we're witnessing yet another outbreak wave. However, we still don't really know to what extent different natural and anthropogenic factors are responsible for these outbreaks. There are 3 hypotheses that have been around for a long time that have the greatest traction still in explaining these outbreaks. On the one hand, the natural life history of COTS, especially their extraordinary fecundity, predisposes them to undergo these major population fluctuations. And on the other hand, anthropogenic factors such as terrestrial runoff and the removal of predators have been proposed to likely contribute to the incidence and severity of outbreaks, at least in some locations. Let's briefly focus on the predator removal hypothesis, which is relevant for this current research that I'm presenting. The underlying mechanism proposed here is that predatory fishes or other predators that are more abundant within no-take areas because of limited fishing pressure are either directly or indirectly regulating COTS abundance and limiting the incidence or severity of their population outbreaks. This hypothesis was first posed by Robert Endian in the 1960s when it was focusing on giant triton, and he noticed that some of the first outbreaks of Crown-of-Thorns starfish were happening in areas where there was a lot of removal of giant triton snails, but it has since focused more or less on predatory fishes. In 2008, the seminal paper by Hugh Sweetman on the right came out, which showed that the incidence of outbreaks, specifically on mid-shelf reefs, which are those black bars, was proportionally much lower in no-take areas or green zones than in zones open to fishing. More recently, further analysis corroborated that outbreaks were less likely on reefs close to fishing, and this paper on the left by Frederick Kroon et al. Also reported that the abundance of predatory fishes was a lot higher in those green zones. And the paper on the right provided yet another line of evidence showing that the prevalence of sublethal injuries was higher in green zones. So there appears to be somewhat of a zoning effect, at least based on spatial outbreak patterns. The problem is that we're still lacking some of these critical links in our understanding of these patterns, as we're yet to quantify or compare relative rates of predation or risk of predation between areas closed and open to fishing. So the current study intended to fill this gap and compare risk of predation within different fisheries management zones. And we obviously also wanted to relate any differences in predation to the relative abundance of potential predators. The two study regions were the Lizard Island region in the northern GBR and the Townsville region in the central GBR, each including reefs within green zones close to fishing, yellow zones where fishing is restricted, mostly to recreational fishing, and blue zones which are essentially open to fishing. We recently wrapped up the field data collection for this project, and over the past 2 years we've conducted 78 predation assays across these 6 locations, which include observations for more than 312 starfish. So that's the basic setup. So we set starfish out near the edge of the reef, and then we basically go back 24 hours later. That's sort of the time frame we worked out, and go back and score predation. So that includes partial predation. So if a starfish, for example, lost 3 arms, it would get a score something like 0.2 or 0.25, depending on the body size. And then a total predation, so the entire starfish was consumed, would be a score of 1. We also set up time-lapse cameras to try and capture predation events and identify the key predators. At each of these sites, we also conduct comprehensive surveys of the local fish and benthic assemblages, which of course include the abundance and size of all potential predatory fishes. And we also estimate the local densities of adult COTS in the area using the salad method, because the role of predators will likely vary depending on the local densities of COTS. When deploying the starfish, we also record a range of other factors, including the size, the reproductive status, sex, if applicable, and any pre-existing injuries. Of course, this kind of predation assay does not provide us with absolute rates of predation or mortality that we can just take and plug straight into population models. But it does give us unprecedented insights into relative risk of predation, as well as the identity and abundance of key predators. So that's probably a good point to circle back to this morning and thank Guju for raising the important questions: who are the enemies of Crown-of-Thorns starfish, which he highlighted in his welcome as the hot topic in reef resilience work. I did not ask him to say that, but obviously it very much highlights the importance of this question and this research that we've been conducting. So let's have a look at some of the predators we recorded using the time-lapse cameras. Of the total predation recorded, 55.3% was ascribed to just the Spangled Emperor, Lithrinus nebulosus, and another 35.5% of predation occurred when both Lithrinus nebulosus, one or multiple, and a Starry Puffer, Erothon stellatus, were captured feeding. Together, these two species contributed to more than 90% of the predation recorded across all those predation assays. And up the top in red, you can also see that another 6.1% of predation was ascribed to the combination of Lithrinus nebulosus and the Titan triggerfish, with only 3% remaining for all other putative predators of adult starfish, which included another pufferfish species and one giant triton. What sticks out when looking at this pie, as well as the actual underlying footage, is that it appears that Lithrinus nebulosus is in pretty much all cases necessary to get the predation party started, and then in many cases the Starry Puffer sort of joins in at the same time or shortly after. These two species were the only species recorded to consume entire adult starfish, which included even some of the biggest individuals that we deployed. Aside from these, we've recorded various other species taking bites, but only after there was already significant damage to the individual, especially when things like Paloxica or gonas are floating around. That's when butterfly fish and everything comes in. But it does suggest that out of the many dozens of fish species that have been in the past proposed to feed on adult Crown-of-Thorns starfish, most of them are just scavengers and do not actually kill and consume entire adults. Across all sites and zones, the mean predation rates recorded to date was about nearly 20%, ranging from 0% where none of the starfish were touched at all to 75% where 3 out of the 4 deployed ones in that predation assay were fully consumed. Forgive the very basic figures at this early stage, but I think the data speaks for itself. Importantly, when comparing the overall rates of predation among those different fisheries management zones, we can see that predation was 3.6 times higher in green zones compared to blue zones and 2.8 times higher than in the yellow zones. Clearly, the adult COTS deployed in the no-take areas were at substantially higher risk of predation, supporting the zoning effect and the predator removal hypothesis. Now looking at the zoning results, but split by region, clearly the zoning pattern we detected is quite consistent for both regions. For the Lizard Island region in northern GBR, predation was 3.5 and 3 times higher in the green zone compared to the blue and yellow respectively. And for the Townsville region in the central GBR, predation was 4.5 and 3 times higher compared to blue and yellow respectively. So the logical next step is to analyze the fish community data and other factors such as the size and the reproductive status of the animals. And other important link to test will be to see whether these clear differences that we found in predation relate to the spatial variation in the abundance of key predators, particularly based on these results, the Spangled Emperors. Some early key takeaways from this work so far include that it shows that we previously vastly overestimated the number of predatory fishes that can kill and consume adult starfish. It appears to be really just one primary predator and a couple more in total, at least at the reefs and sites and regions we worked at, with other fishes previously believed to consume COTS likely just being scavengers at best. The overlap between predators and fisheries target species is also quite low. Common target species such as coral trout were never observed to feed on any of the starfish. At the same time, the Starry Puffers and the Titan triggerfish are obviously not fisheries target species. The only overlap really seems to be the Spangled Emperors, which are a popular target of the recreational fishery and as well as a secondary species for the reef line fishery, which could be part of the reason why our study demonstrated that COTS experience a substantially higher risk of predation in no-take areas than in blue and yellow zones, so that's where potentially that recreational part comes in. Our results corroborate the hypothesis that no-take areas and limited fishing pressure could regulate COTS abundance, at least in some locations. These data on key predators and zoning effect also provide opportunities to improve the ecological underpinning of both modelling as well as management. Ecological data corroborating the zoning effect of outbreaks could be useful to model population dynamics and refine ecosystem models for targeted decision support. Lastly, these data also allow us to assess the potential role of fisheries management and zoning in moderating COTS outbreaks, which includes potentially the increased abundance of the predators identified in this project and other projects identified in the next talk, particularly for the adult stage, the Spangled Emperor. Thanks for the COTS Control Innovation Program, as well as the Lizard Island Research Station and all the crew, collaborators and researchers involved in this work. Thanks.
I'll just check in online. All right, we'll come back to that if we have any online questions.
A great talk. If we flip the question a bit to the predator as opposed to the prey, if fish emperors are really kind of the only ones that eat the adults, that would suggest they could benefit a lot from outbreaks, right? So if they're monitoring data on their abundances, and do they go boom and bust with the outbreaks of COTS?
Yeah, that's a great question. I guess there's two sides to this. Obviously, Spangled Emperors, similar with Starry Puffers, have a pretty general broad diet, so they're not just specialised on Crown-of-Thorns Starfish and feed on various inverts. But at the same time, when we look at monitoring data, there isn't really much on these species. I'm pretty sure, correct me if I'm wrong, but the LTMP doesn't record Spangled Emperor and Starry Puffers and some of those predators. So we'd probably have to look at fisheries data potentially, which obviously has some limitations to it in interpreting and matching up these fluctuations of both COTS and the fishes. So yeah, and our own sort of site-specific fish surveys are obviously too short-term to dig into any sort of temporal variations in the fish abundance, unfortunately, but it's a good point.
Sorry, I might just build on that one. So my master's degree in the early 90s, like 93, we looked at fishing club records from the 50s to 1990, and there was trends in some of the target species, like Lathrinids over, I think it was 7 or 8 year period, so it was quite cyclic. But my question is, so there was Townsville and Lizard Island. There's a huge amount of difference in the fishing effort, particularly recreational fishing between Townsville and Lizard Island. I'm just wondering if you tried to standardise the actual fishing to tease out, is it a zoning effect or is it just the location where the zoning was applied, and look at some of the historical differences. And it might be a case that there's, for a small number of sites, it might be just it was just one of those things, we put the zones where it was, and there was a lot of negotiations around where the zones went, and a lot of background to that, so yeah.
Yeah, no, I think halfway through the project there seemed to be a bit of a difference in the yellow zone, but now that we've done plenty of trips and a fair bit of replication, it's sort of balanced out, and we see that same green, yellow, blue effect at Lizard as well. In the first place, we put it down to obviously a lot more recreational fishing at places like John Brewer, I think is the yellow zone, as opposed to up north. But yeah, in general, it would obviously be good to do this entire thing across the length of the GBR and have like various data points. The fact that we only have 2 probably rules out too much emphasis on that, but if we had a bit of a gradient, then there would be a lot more we could do in terms of standardising data.
Final question. Do you just put a 360-degree camera on a stick and glue it to a starfish, or what was going on in those photos?
No, so these are sort of mounted cameras, and we put them on time-lapse mode. I think AIM's developed some really fancy things that we trialled once at Lizard Island, where you got 24-hour continuous recordings of like a 2x2 metre area, but unfortunately we didn't have that available for most of this project. No, these are really basic time-lapse cameras, just focused on the deployed starfish to try to capture as many events and predators as possible. But yes, of course, it would be ideal to have a very realistic, massive arena, and we could sort of just let them run around. But yeah, with what we had to work with a few years ago, we thought this was the most appropriate way to try to catch as much action as possible.
Great, thank you.
Thanks.
For our last talk, we're welcoming back Pete.